All right. So a vertical asymptote happens whenever you have a value that creates 0 in the denominator. You see the 1 over x. If you plug in 0 in there, you're going to get a vertical asymptote because you can't plug it in. Now, if we had a different function, like let's say this guy on the left, 2x plus 1, x plus 1 on the bottom, you agree that if I plug in -1, it's going to create 0 on the bottom, right? So then hence you have a vertical asymptote at x equal to -1. So x equal to -1 is an equation of a vertical line. I don't mean the value -1, I mean the line. Okay. I mean this. Oops. Okay. So as we can see, x equal to -1 is your vertical asymptote. So it's a value that it approaches, it gets infinitely close but never crosses. So an asymptote is kind of like a boundary. The function can never be 0, but I mean, in this case, sorry, it can never be -1. It gets infinitely close but never gets there. Okay. So in order to find them, you have to just set the denominator to 0, and whatever values you find, those are your vertical asymptotes. That's all you got to do. So for number 4, right, the vertical would be happening at x equal to 0, right? The line x equal to 0, because that's what makes the bottom 0. Oops. For this one, it is quadratic. Find all vertical, or oh, I need the horizontal. Okay, we haven't talked about horizontal yet. Now, there's a set of rules for horizontal. Let me see if they're in here. Oh, here we go. So it depends on the power of the degree of the denominator and the numerator. I like how this is phrased. Let me see. I feel like this is more complicated than it needs to be. Yeah, here. Let me explain it a different way. I think I don't have my formula, but here. If the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is y equal to 0. So if the power on the bottom is bigger than the degree, the horizontal asymptote is y equal to 0. Now, if the degree of the top and bottom are equal, then you divide the coefficients you divide the leading coefficients of the numerator and denominator, and that will be your horizontal asymptote. So those are 2 cases. The third case is the annoying one. Let me see if the third rule is in here or not. I don't want to see a video. Here, this is the one that kind of sucks. If the numerator's degree is more than the bottom, so if the top numerator is bigger, then you'll have an oblique asymptote, so it'll have an angle to it. Okay. And in order to find the equation of that guy, you would have to do long division. That's why it sucks. Anyway, I'll send you all this sheet in a moment that has those summarized rules. So right here, the degree of the bottom is bigger. So you would say y equal to 0. So vertical and horizontal. The degree of the top is a 0, degree of the bottom is a 2, because there's no x on top. Is there any questions on number 4? So number 5, the degree of the bottom will be 3 once you FOIL it all out, expand it. Yeah, I just gotta remember them. I mean, I recommend just having them written down for your formula sheet on test 3. That way you don't have to worry about it. This guy, x equal to 7 would be the vertical, y equal to 0. Okay, so 5, 4, and 5 are the same kind of question. Check out 6 though. What is the degree of the top and bottom here? Yeah, degree of a numerator is 1, degree of the denominator is also 1. The highest power is x, x to the first. So since they are the same, the horizontal will equal whatever number is in front divided by basically, let's say, you look at the coefficients of the highest power. So here they're both 1, right, in front of the x. So the horizontal would be 1 over 1, which is just 1. That one's not that interesting. What makes the bottom 0 here? Oh, you're right. 1 over -1, which is negative. Thanks, good catch. What makes the denominator 0? 6. So you would say x equal to 6 is your vertical asymptote. Now, if we graphed it, we should see that that's true. The 6 minus x, right? Dang it. 6 plus x. Okay. So you can see vertical asymptote at 6, right? There it is. It's approaching it. Now the horizontal is -1. See how it doesn't cross this line either? So y is equal to -1 because it's the coefficient of the top, 1 divided by the bottom, -1, gives us this. Whatever makes the denominator 0 is going to be the vertical asymptote. Okay, so now number 7, I'm going to show the work this time. But do you guys have any questions on 6? Let me just go ahead and write on here instead. Let's see. So Define vertical asymptote. So this will be the steps for that. Vertical asymptote. Do this. Set the bottom 0. Haven't been doing this, but here we go. Solve for x. So x equal to -4/7 is going to be the vertical asymptote. So this equation gives me a line. Now, what is the degree of the top and bottom? Yeah, it's going to be 1. So take the coefficients of the vertical horizontal asymptote. It's going to be y equal to, right, the coefficient of the top divided by the coefficient of the bottom. So this equation of a line is the horizontal. Any questions on 7? Sorry, got distracted. All right, cool. Okay. The vertical asymptote. So here's the rule, right? We set the denominator to 0 and solve. You can factor or you can do the square root property, it doesn't matter how you do it. But we will have 2 values. So we have 2 vertical asymptotes at -2 and 2. What is the degree of the top of the numerator? It's going to be 3. And the bottom?
2.
Yeah, it's going to be 2. So we said in the notes or in that random web page, if the degree on top is bigger, there is no horizontal. There is an oblique, but there is no horizontal. So just put these 2 in there. And we only have vertical for this guy. Any questions on 8? Not too bad, right? The 9 would be the same kind of deal. Yeah, let's do 10, guys. For vertical. Set the denominator to 0. Find out when the division by 0 happens. Is this factor pretty?
Yeah, it should be 3 and 2.
Well, 3 and 2 does not have to add up to 1. It looks like it should, but I'm starting to think it doesn't. Yeah, it does not factor. We would have to do quadratic formula to check. Alrighty, let's see. 1 squared is 1, so who cares? Minus 4. Oops, what does this look like? I mean, you should stop it here at this point, but is there a solution? Oh, is there a real solution? So since there's no real solution, there is no horizontal. The bottom is never 0. So there's just going to be a horizontal, that's it. No vertical, I meant to say. So y equals the leading coefficient. So divide this coefficient by the one in front of the x right here, this invisible 1. So -2 over 1 equals -2. But we only got this guy. Do you see the issue with 11? Same problem, right? There is no sum of squares, so this has no vertical. So you can try to solve this for 0, it's not gonna happen. Let's just look at the horizontal. This number divided by this one, because the degrees are the same. We only have horizontal. Okay. Any questions on this idea? I think I'm gonna move on to something else. Can you find horizontal? Can you find vertical? Asymptotes. Number 15, they have us just match the graph. So use the fact of the horizontal, vertical and horizontal asymptotes to help you out. That's pretty much it. So let's move on to something else. Okay. Also, I graded your exams. Whatever grade you see there is your final grade for test 1. I gave most of you a lot of extra credit. No worries. Thanks for dealing with the ISLO. I know that's annoying, but they're forcing me to do it. I had no choice. But it's over now. We're good. I think 99% of you did it. I think that's good enough for them. 4.2, I think is pretty short. It's graphing. I'm not gonna really be too hard on you on the graphing sections. But one moment. So number two. Let's see the domain. So as we've been talking about this whole time, there's certain numbers you can't plug in. So those numbers happen to be the asymptotes. So anything that causes division by zero is a number you can't use. So we should see that all numbers are cool except -3. Right? Any other number is fine. Just that one number is not fine. Now to find intercepts, the rule is to find x-intercept, let y equal 0. And solve for x. For y-intercept, let x equals 0. And solve for y, which means that you'd have something 0 and 0 something. Vertical. What is the vertical asymptote? You can do that real quick, right? Yeah. Horizontal. The degree is bigger on bottom, so it's gonna be gonna be 0. So I'll just plug in these numbers and we can find the intercepts. I don't think. Oh, maybe. No. If I plug in 0 for x, I'm gonna get 1/3, right? If you plug in 0, right, this is just gone. For the x-intercept though, let y be 0. I want to say there isn't one. Let's graph it and see. Yeah, oh, obviously, I'm stupid. We should have seen that, right? If we have horizontal asymptote at y equals 0, then how could it ever intercept the x? That's not possible. There is none. Oops. Anyway, any question on this? There's not really much to say. You guys cool how I did the intercept? I didn't really show work there. Does it make sense or is it okay? All right. Just let me know if you need any extra steps or whatever. Three would be the exact same thing, except they want you to match a graph. So I guess they did here too, but once you have the asymptotes, you can kind of rule things out in an intercept. So whenever you have a horizontal asymptote of y equals 0, you will not have a yeah. So if we have a horizontal asymptote at y equals 0, there will not be a x-intercept. Well, that won't happen. This guy has a horizontal asymptote where though? Number 4. Yeah, it looks. Remember, it's the numbers on the x. I think doing the asymptotes first kind of helps. So the bottom, obviously. Right, it'd be 2 over 1. It's this coefficient and this one. So since horizontal asymptote is not 0, there will be an x-intercept this time. In order to intercept the x, y has to be 0. In order to intercept the y, x has to be 0. And since we have the vertical asymptote, we should know that that is the one place we cannot cross. So all real numbers are cool for the domain except this one. Then I'll just solve for the x-intercept. So let's do that first. We set the y equal to 0. Solve for x. Multiply both sides by x plus 2 gets us to x plus 2 times 0. X plus 2 times now we got 0 equal to 2x plus 3. Subtract the 3. Divide by 2. So we got negative 3 over 2. This is the x-intercept part. Y-intercept, you just plug in 0. So in other words, input 0. It just so happens that it's 3 halves. That's funny. Weird. You guys cool on number 4? Alrighty. Would like to do any more of these problems? They seem to all be the same so far. Let's see, maybe at the bottom they change. Really? For D. There's an extra step right here. Same with 9. See how they're actually doing the oblique part? They didn't add, oh, here it is. Find any vertical or slant. Like use the word slant instead of oblique. Same thing. Okay. So let's do this guy. First things first. What value can we not use? Yep. So the domain would be everything except that one number. X-intercept, we'd have to solve it. Y-intercept. Plug in 0 for the X. These would be gone, right? But I can't have division by 0, can I? So there is none. There is no y-intercept. In order to find the horizontal, vertical, you can actually just set the numerator to 0. I think this is easier. Solve for x. So this time let's do the square root thing. Instead of factoring. No reason. I'm just doing it. Smaller one first. Bigger one second. Okay. What is the vertical asymptote? Yeah, x equals 0 is the vertical asymptote. Now to find the slant, we have to do long division. Oh, oops, I forgot. When you do long division, you kind of have to add the missing parts. So we got no quadratic or no linear term. So x goes into x squared, x times x is x squared. Subtract it, that's 0. Bring down the -4. Technically, you would bring down the 0 first. X can go into that. So The oblique will be y equal to x, I believe. Let me double check. So whatever you get on top, the quotient would be the slant part. Does that make sense? This piece is where this came from. Are there any questions on 9? Okay. Yeah, that's pretty much it. You can use the graphing to guide you. Just make sure you can find the intercepts on paper, find the oblique, and find the vertical and horizontal asymptotes. Slanted, vertical, horizontal. One moment. Okay. That's pretty much it for all the material for tests, unit C test. Currently 7:20. Let me see how long this review is. Do I have? Oh, here it is. Hey, just go ahead and go through it. It's fine. Okay, so given the polynomial, it's pretty straightforward, right? What is the degree here? The highest power is, yeah, 13, you're right. 13 right there. What is the leading coefficient? Yeah, it's going to be the number on the highest power, so yeah, it'll be 420, right? And behavior. We said if it's even, it should be kind of like a parabola type, right? Either A or C. Which one would y'all choose? Oh, actually, it's not even. I'm lying. Not bad. The highest power is 13, so it's going to be B or D. But since it's positive 420, which one? Yeah, it looks like B. Mhm. Any questions on number one? Y'all see why the end behavior is this and what these definitions mean? All right. What is the degree of number two? The highest one is 7, so it has to be degree 7, highest power. So that means that the highest number of zeros is going to be what? Yeah. What's the maximum number of turning points? But we said it's always going to be the degree minus 1. So n minus 1, where n is your degree. So it should have 6. Number 3 kind of requires work. So let's write this one down. On this one, let me just write a note here for you. Hold on a sec. Well, there's a couple of ways to do number 3. The only one I can think of at the moment is using factoring or synthetic division. I wrote a note for you for number 2. Max zeros is equal to the degree, which in that case was 7. Turning point is n minus 1, where n is the degree. So number 3, I'm going to try factoring first. So to find x-intercepts, you set it to 0. Switch the mic to closer. Factor x squared. So that'll be x plus 3. Factor -4, that'll be x plus 3. Yeah, it looks like good factors, no problem. Factor x plus 3, and we get x squared minus 4 equal to 0. So set each one to 0. X equals -3. X equals 4. So x is plus or minus 2. So -3, 2 minus 2. It's like this guy. This one looks like the same question, but y-intercept. If you plug in 0, it would all be gone except -12. So the y-intercept would be 0, -12. Any questions so far? Okay. Number 5 wants us to do long division. And then write it in that form. We'll do it on the next page because long division can be long. Use polynomial long division. Algorithm to find the quotient. Alrighty. Let me write this question down. I'll switch over. All right, so divide x into 5x cubed. So that is 5x squared. Now multiply 5x squared times x plus 2. That gives us 5x cubed minus 10x squared. So that'll go here. But you got to subtract it, so this becomes plus minus. 5 minus 5 is 0. Negative 6 plus 10 is a 4. Okay, now start again. X goes into that. Garbage. That many times. Now multiply the divisor. Giving us 4x squared plus 8x. So that goes here. So it'll be minus, minus. So it'll be 0. Negative 28 minus 8. X goes into that. I'll do this later. Divide this by x, giving us negative 36. Negative 36 times your divisor. So that'll be negative 36x minus 72. I guess I could go ahead and do it. But subtracting them makes them plus, giving you 0 and 20. So the answer they want is going to be see if I can fit it in here. Equals to this quotient plus your remainder. So they want this part. Any questions on the long division? I think you only have to do it once. I think. Let me see. Yeah. So you gotta do long division one time. Because it takes forever. You guys cool on number 5?
Can you go back to the paper for a minute?
Oh yeah, I'm
Please.
sorry. Oops. Okay. Were you still looking at number 5? I'm sorry. Okay, I'm gonna assume yes. Let's do 6. Use synthetic division. So we got 4x cubed minus 15x squared plus 11x minus 10 over x minus 3. So essentially what we're doing is we're seeing if we're checking if this is a factor, or think of this as your divisor, right? Because if this is a factor, then 3 is a 0. So check. And even if it's not, we're just trying to do division, it doesn't matter. Just do it like you've always done it. Bring down the 4. 3 times 4 is 12. Negative 15 plus that is negative 3. 3 times that is negative 9. Add that up. That's 2. 3 times 2 is 6. Negative 3. Okay. So here's my synthetic division. So the quotient will be 4x squared minus 3x plus 2 minus 4 over your divisor. So this is the remainder, right? Any questions on 6? Number 7 we did last time. All you got to do is list the possible zeros. Given this function, we said possible zeros will be the factors of the constant term. So plus or minus 1, plus or minus 2 over the factors of this guy, leading coefficient, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. So they would be 1, 1/2, 1/3, 1/6, 2/1, 2/2, which is 1, so we don't write that again. 2/3. 2/6 is a third, so that's it. So we said in order to find them, you find these factors and the factors of 6. You can do 1 over that one, 1/2, 1/3, 1/6. Then the same thing, 2/1, 2/2, 2/3, 2/6. anything that repeats is not used a second time. Any questions on 7? I'm hoping it's familiar from Monday. So the list we found on 7, use it to start dividing. They want us to start using 1, so that's cool. Use synthetic division for problem 7. It told us to use 1, so cool. 6, 7, negative 12, 3, 2. 1 times 6, 6 plus that is 13. Double check that. 1 times 6 is 6. 7 plus 6 is 13. 1 times 13 is 13. 13 minus 12 is 1. 1 times 1 is 1. 1 plus 3 is 4. 1 times that is. I guess if they said k is equal to 1, they may have meant k equal 1 is a factor. Or maybe they're not telling us at all. I don't know. We'll try negative 1. See if I'm right or not. Nope. Okay, I guess they're just telling us start from 1 just cause, but whatever. Although, let me make sure I wrote the question down. 6, 7, negative 12, negative 3, 2.
Instead of negative 3.
Ah, here it is. Yeah, something was off. Okay. It was me the whole time. So there it is. Sorry about that. So we got 1, 0. So now we got x minus 1 as a factor times 6x cubed plus 13x squared plus x minus 2. Okay. Let's try minus 1. Six, 13, 1, negative 2. Negative 1 times 6. 6, negative 1 times 6 again. No, that's 7. not -1. Okay. Let's try 2 just because it's easy. I don't want to try the fractions just yet. Bring down the 6. 2 times 6 is 12. Add that up. That is a 25. That's not going to happen. -2. Bring down the 6. -2 times that is -12. Add that up. It's a 1. -2 times 1 is -2. Add that up. It's a -1. -2 times that is a positive. Here we go. Cool. So now we got x minus 1 times x plus 2 times 6x squared plus x minus 1. So that's our factored form. So now do quadratic formula on this guy, and we'll have the last one. So -1 and -2. So it's going to be this. So when you do quadratic formula, you end up with these two. But I'm low on time, so let's move on. Number 9. So if they give us zeros of 3 comma 2 plus I, we know that the imaginary part comes in pairs. So the function has to be x minus that 0 and x minus 2 plus I and x minus 2 minus I. So we're going to have to FOIL it out. So this will become x minus 3 times, so this is a conjugate, so you can just say, you know what, that's a squared minus b squared. Hold on. No. That's not true. To multiply this out, you would just first distribute this nonsense. X times x, x times this. This times that would be another x. This times this would be plus 4 minus 1. Distribute this garbage. Minus minus. This should be a plus. This should be minus. This should be plus, minus, minus. So the I components will cancel. Sorry, it's kind of messy there. You could have distributed the minus first and then foiled if that's easier for you. I went ahead and did it as is. I don't know if that's more confusing. But once you get it all down, you'll get to here. Now just distribute x times that whole thing minus 3 times that whole thing. So that'll be x cubed minus 4x squared plus 3x minus this garbage. There we go. That was annoying. Looks like it will be. Dang it. Yeah, you know what? We'll just have to continue next time here. I'm trying to rush it. I'm just making it worse. I'm sorry. We're out of time. We'll continue the review here next time. No big deal. Let me take roll and we'll call it a day. Aaliyah Carmichael here. Jamila. Gabriel Eastridge. Victoria Espinosa. Haley Gibson. You know what? That is the completely wrong class. I don't know what the hell I'm doing. Let me start over. Abdallah. Noman, I see you. Daniel, Nagita. Trevor Brown. Joshua Correa.
I'm here, sir.
Megan Dean.
I'm here.
Madison. Ella Dunlop. Stephen Fogel. Alexander Garza. Here. Jorge Guevara.
Here.
Tyler Just. Liliana Manila. Victoria Mannion.
Here.
Jose Mauricio.
Here, sir.
Victor Ramirez. Jaden Ramos. Jolene Cias.
Here.
Miranda. Carlos.
Here.
Frederic.
Here.
And Dylan Willis. All right, guys, we'll stop here. I'll see you next time.
Have a good night, sir.
Have a good night.